Hello! Today we are going to cover 8.3 special right triangles. We are first going to start with the construction handout 1 to kind of discover how these special right triangles work. So we are going to construct these, the first one starting with the square. So we have a list of directions here. We are going to mark all angle measures in the square. These are all just 90 degrees. Okay? Then we are going to mark the lengths of the sides of the square as 1 unit. So I know a square has all the same side lengths. They are all 1 unit in this case. Then we will draw a diagonal of the square to make 2 triangles. Do we have 2 triangles now? And then measure the length of the diagonal. Now, we have a triangle here. It is a right triangle, so we can do the Pythagorean Theorem to find the length of that diagonal. So we have 1 squared plus 1 squared equals x squared. We'll call this x. So we have 1 plus 1 equals x squared, or 2 equals x squared. So x is actually equal to the square root of 2. Okay? So now we can transfer all the measurements to the right triangle shown. So we have 90, we have 1 unit, we have 1 unit. The hypotenuse is square root 2 units. And then we need to figure out what these angles are. Now there's 2 ways that we can go about doing this. We can notice that this is actually an isosceles triangle because these side lengths are equivalent. That means the opposite angles must be equivalent, making these 45. Or you can recall that in a square, the diagonals are angle bisectors, so it has to be 45. Either way, we now have a 45, 45, 90 right triangle. This is one of our special right triangles. This triangle here, we are going to use a bunch, so keep that in mind. Then, we have another right triangle. This time we start with an equilateral. Mark all angle measures of the equilateral triangle. We know those are all 60 degrees. And then mark the lengths of the sides of the triangle as 2 units long. Now this is just the easiest way to set these up. You could have made them a different unit long, but it would make it harder to solve. Step 3, cut the equilateral triangle in half by connecting the upper vertex to the midpoint of the bottom side. So this is a midpoint, meaning these are cut into congruent pieces and making this 1 unit on this side. And then measure the length of the altitude of the equilateral triangle. Notice we once again have a right triangle here, so we can use Pythagorean Theorem to go ahead and solve for the altitude. We'll call it x again. So this time we have the hypotenuse. We're trying to find a leg length, so we have 1 squared plus x squared equals 2 squared. So x is going to equal the square root of 3. And then same as last time, we will transfer our measurements over to our right triangle shown. So we have 2 units, we have root 3 units, we have 1 unit, we have our 90, our 60, and the last thing is we need to figure out this last angle, which is 30 degrees. And this is called a 30, 60, 90 special right triangle. And we will also use this a whole bunch, so keep that in mind. Now, if you pull up the actual notes, you'll notice we are talking about special right triangles today, and you guys will be able to use the properties of 45, 45, 90s and 30, 60, 90s. Now, we actually went through all these properties, so if you want to pause and read through this on your own, you can. I will point out that there are formulas that go along with these. I am not going to use the formula method. You can use that. That just feels like a lot of memorization to me, a lot more memorization than I'm going to teach you how to do it. What we are actually going to look at, and we'll look at it on this first example here, is the fact that we can set up proportions using similar triangles. So notice those triangles that we did on the last page, those are similar triangles to these two different ones on this page. We have angle-angle similarity, having 45, 45, 90s, which means the sides are proportional. So we can set up a proportion. This is how I prefer to do it. You could, yes, use this equation, find the hypotenuse based on the leg. Totally valid. Oops, typo there. Root 2, not root 3. Or you can set up a proportion. So, to set up a proportion, I am going to do leg over leg equals hypotenuse over hypotenuse, so 9 over 1 equals x over root 2 go ahead and cross multiply to solve. You get 9 root 2 equals 1x, but if you divide by 1, that doesn't change anything, so 9 root 2 equals x is your solution. We have the same pair of similar triangles again. This guy, as long as you have a 45, 45, 90, and this guy, who is a 45, 45, 90, can be set up as a proportion. So we're going to do it. We have our leg length, 1 over 6 root 2, equals root 2 over x. We are going to cross multiply. Once again, we get 1x, or just x, equals 6 root 2 times root 2. Now the thing is, this is a little bit different than we saw in the last problem. You need to take 6 times root 4, because root 2 times root 2 is root 4. And root 4 is actually just equal to 2. So we get x equals 12 as our solution. Now I'm just going to work through these next two. Follow along, maybe try to challenge yourself to write out what our special right triangles are without looking back at old ones. And follow along with me. So we're actually already done with that first one. We'll set up the next one. And there's the next one. All right, same process as the previous slide, just different solutions. Now, the next two slides, they get a little different because you're actually given the hypotenuse and need to solve for the leg length. So, you still have the same similar special right triangle that you can draw. Still set up that proportion. Still cross multiply. It'd be really nice if we could be done there. A equals 8 over root 2. The problem is we cannot leave a radical in the denominator. We need to rationalize that. It's bad form to leave it in the denominator. So we multiply by what I like to call incognito 1. This guy is actually just equal to 1, so it's not changing what anything equals. It's just helping us simplify. So we get 8 root 2 all over square root 4, because these two multiplied is square root 4. And then square root 4 is actually just equal to 2. And then you can reduce here and get 4 root 2. Something to point out, you can't reduce these. Root 2 is actually like 1.4 or something. Those are not reducible, okay? You can reduce on the outside though, like we just did. So we'll do the same thing on the next one. Set up my similar triangle, like so, and I have 1 over b equals root 2 over 6. Cross multiply. I get root 2b equals 6. Now I have b equals 6 over root 2. I want to go ahead and rationalize, so I take these multiplied by the denominator in both the numerator and the denominator, incognito 1. So we get 6 root 2 over root 4, which is 6 root 2 over 2, which is 3 root 2 as our solution for B. So like I said, the easiest way, the most simple way, is probably just memorizing this special right triangle and solving using proportions, because we've done that a lot. If you prefer, there are equations like we had up with the theorem, or you can think of it this way. If the length of the leg is given, the other leg is identical to the first one, that's pretty simple. It's an isosceles triangle. And the length of the hypotenuse is root 2 times the given leg. Or if the length of the hypotenuse is given, finding the length of each leg by dividing the hypotenuse by root 2. So you can think of it that way too, instead of setting up a proportion. Either way is totally valid. Choose your favorite. Okay, and then we also, on the first page we looked at, talked about properties of 30, 60, 90 triangles. So if you want to pause and read through this, go for it. Otherwise, there is formulas here for finding the hypotenuse, long leg, and short leg. Like I said though, I do prefer just using my special right triangles and solving with proportions. So my special right triangle, if you recall, we have 60, we have 30, we have 90. Remember, the smallest side is across from the smallest angle. The medium side is across from the medium angle, and the biggest side is across from the the biggest side is across from the biggest angle. So there is our special right triangle, and we can now set up proportions based on that. Okay? So I know my smallest side, 4 root 3 over 3, has to be paired up with my smallest side, 1, of my special right triangle. Then I can solve for x or y first. I'm going to solve for x first. Over, this is my medium side, so over root 3. Okay, now I cross multiply to solve. It does look kind of weird because we have a fraction and a fraction. Don't worry, it'll go away right here. We get 1x, or just x, equals 4 root 3 over 3 times root 3. It's technically like times root 3 over 1, so you don't have to worry about the denominator too much. You end up getting 4 root 3 times root 3 is 4 root 9 over 3. Now root 9 actually simplifies, so 4 times 3 over 3. And then you can say that's 12 over 3 equals 4, or you could have saw that those just went ahead and reduced right away. Either way, you get that x equals 4. Now from here, I don't always suggest using what you just found, because if you happen to have gotten that wrong, you could make yourself get y wrong as well. I know that we just got x correct, and it also is much simpler than the short side. So I'm going to go ahead and actually just use it to solve for y. So I will have 4 over root 3. that's long side over long side, equals y over 2, hypotenuse over hypotenuse. I go ahead and cross multiply. I get root 3y equals 8. I do have to divide by root 3, which means I'll have to rationalize here. So I end up getting y is equal to 8 root 3 over root 9. We do have to go ahead and take root 9 and simplify it, though. Actually, I'm just going to do it here. Square root of 9 is actually equal to 3. 8 divided by 3 cannot reduce, so we have our answer for y and our answer for x. Okay? And then on this slide, we do something very similar. I am going to replace these with x and y instead of calling them by their segment names. Just makes it a little easier for me. I have a 30, 60, 90. Make sure on your worksheet that you really pay attention to 30, 60, 90. Don't try to do a 45, 45, 90 similarity with a 30, 60, 90 triangle. Obviously, that's not going to work out. Make sure they are matched up correctly. Okay? I wrote out my special right triangle. I have the one I'm trying to solve for. Notice, I didn't point this out in the beginning. You can't use Pythagorean Theorem here because you only have one side length given to you. If you had more than one side length given, by all means, use the Pythagorean Theorem. But fortunately, it's a no can do in this situation. So what we want to do is we want to take long leg 4/3 over, for root 3 over root 3 equals, I'm going to solve for x first, x over 1. Cross multiply. You end up getting 4 root 3 equals root 3x. Now, you could have seen this a different way and solved much faster than we are doing here. And if you didn't, that's totally fine. So we end up getting 4 root 3 over root 3. A lot of you probably just want to go ahead and try to rationalize this. But hey, if you can cancel something out before you rationalize, go for it. Root 3 over root 3 just cancels itself out. Whether you rationalize or you just cancel, you're going to get x equals 4. Once again, I am going to use that x equals 4 because it just makes my life easier. I know 4 over 1 equals y over 2. I can cross multiply to solve, and I get 8 equals y. Okay, that one was pretty simple. And then once again, we have a summary of the 30, 60, 90 right triangle. If the short leg is given, the hypotenuse is 2 times the short leg. That's why this one was so simple. It's literally just 2 times the short leg. And the long leg is root 3 times the short leg. If the hypotenuse is given, the short leg is equal to the hypotenuse divided by 2. And if the long leg is given, the short leg is equal to the long leg divided by root 3. And then these last ones, I'm just going to go ahead and paste in the solutions to them. Have a great day.